Hello and welcome to the review of trigonometry for the assessment in geometry on Thursday. What we're going to do is in this video, I'm going to do a few examples and then the Edpuzzle will stop the video and have you practice some of your own. So let's get started. Our first example has to do with the Pythagorean theorem. And before we get into the formula itself, we need to know the parts of the triangle. So when given a right triangle, and we know it's a right triangle because we have this little square in the corner, the two sides that form the right angle are called the legs of the right triangle. The side across from the right angle is called the hypotenuse. Now that we know the sides of the triangle, depending on what we're trying to find, changes what method of the Pythagorean theorem we'll use. When you have two sides, two legs, and you're trying to find the hypotenuse, we're going to use a squared plus b squared equals c squared. And since we're trying to find c, which is the hypotenuse, that's the method we're going to use. So let's take the legs, a and b, and substitute them into the formula. So we have 6 squared plus 2 squared. And when I put that into the calculator, I get 40. Now, to finish this problem, let's take the square root of 40. When I do that in the calculator, I get 6.3. The hypotenuse's missing length is 6.3. Now you try one. Let's take a look at another example here. Again, we're given a right triangle, and we're asked to find a missing side given two sides. That's a classic Pythagorean theorem scenario. So again, I'm going to label my triangle here. The two sides that form the right angle are called the legs. And the side opposite the right angle is called the hypotenuse. In this scenario, we're being asked to find one of the legs, given the hypotenuse and the other leg. In this scenario, we would use the formula a squared equals c squared minus b squared. So once again, let's plug our numbers in. Starting with the larger number, the hypotenuse, we're going to do 9 squared minus 4 squared. When I put this into the calculator, I get 65. Step 2, take the square root of 65. And when I plug that into the calculator, I get 8.06 or 8.1. That is the length of the missing leg. Now you try one. All right, let's take a look at another scenario here. In this example, we're given a right triangle, but we're not given two sides. So it eliminates the Pythagorean theorem from a potential tool to use. However, we are given one side and an angle. And when we have that information, we can use trigonometry. Before we get started, we need to understand how to label the sides of our right triangle. Using 57 as our reference angle, we can find that the side opposite the right angle is the hypotenuse. The side across from our reference angle is called opposite, and the side next to our reference angle is called adjacent. Given this information, we looked at 3 trigonometric ratios. The first one was sine. Second one was cosine. And the third one was tangent. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Given these functions here, let's take a look at our example. We have to find PR. PR happens to be the opposite side. We know 3.2, which is the adjacent side. Opposite and adjacent is tangent. So the tangent of 57 over 1 is equal to x over 3.2. When I cross multiply, I get 3.2 tangent of 57. And when I run that through my calculator, I get 4.92 or 4.9. So PR, or the side they're looking for, is 4.9. Here, now you try one. All right, let's take a look at another example here. In this example, we are looking to find the measure of angle X given two sides. Angle X is going to become our reference angle because it's the angle we're looking for. So based on angle X, 8.2 is the hypotenuse, 7.3 is the adjacent, and WV is opposite. Now we're looking for an angle this time, so instead of the trigonometry ratios, we're going to use the inverse ratios. The same combinations apply though. We have sine, cosine, and tangent. Where sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So with these combinations, we're trying to find angle X, and we know the adjacent side and the hypotenuse. Given these combinations, we are looking at cosine, but we're not going to use cosine, we're going to use the inverse of cosine. Now notice in our ratios, it's A over H. So I'm going to start with 7.3, and I'm going to divide by 8.2, getting 27.09 or 27.1 degrees. Here, now you try one. Let's take a look at another example. In this example, we're asked to solve the right triangle. When we solve a right triangle, we have to find all of the missing sides and all of the missing angles. I like to identify what I'm missing so I know what to find. I know I'm missing angle B here, so we'll have to put that on the list. I know that I'm missing side CB, so we'll have to put that on the list. And finally, I can see I'm missing CA, so we'll have to make sure to put that on the list as well. Let's start with the angle. So because all angles of a right triangle add up to 180 degrees, I simply have to subtract 42 from 90 to get the other angle. This is because the 90-degree angle takes up half the measurement of the triangle, leaving us with just 90 left. So if I subtract from 90, I'll get the answer. So 90 minus 42 is going to be 48. So that's 48 degrees. And now one of our answers is done. Let's look for side CB. So from 42 degrees, CB is going to be opposite, CA is going to be adjacent, and 9 is the hypotenuse. So based on this information, I am looking at opposite and hypotenuse, which is sine. So I'm going to use the sine of 42 over 1 is equal to x over 9. Cross multiplying, I get 9 sine of 42. Putting that into my calculator, I get 6.02 or 6. Let's try to find CA using the same method. I know that CA is the adjacent side to 42, and I still know the hypotenuse. Well, adjacent over hypotenuse is cosine. So the cosine of 42 over 1 is equal to x over 9. Cross multiplying, I get 9 cosine of 42. I put that into my calculator, and I get 6.68 or 6.7. So we have all the angles and all the sides solved for. Here, you try one. All right, let's take a look at another example here. I'm given a right triangle with two sides, and I'm asked to solve the right triangle. So first things first, let's make a list of what we need to find. I need to find angle T. I also need to find angle S. And lastly, I need to find side RT. All right, let's start with side RT. So in this right triangle, I have two sides, and I'm trying to solve for the third, a classic Pythagorean theorem situation. I am missing one of the legs, therefore I'm going to use the subtraction method. So let's subtract the hypotenuse squared minus the leg I know squared. 6 squared minus 4.6 squared is going to be 14.84. My second step here is to take the square root of 14.84, and I get 3.85 or 3.9. Let's try to find angle T next. So basically, from T becomes my reference angle, and 4.6 becomes opposite. The RT becomes adjacent, and 6 is the hypotenuse. Based on what I'm trying to find, angle T, I have opposite and hypotenuse, which is going to be inverse sine. It's going to be 4.6 over 6 because it is opposite over hypotenuse. And when I put that in, I get 50.05 or 50.1 degrees. Let's find that last angle now. So what I can do is, because the angles add up to 180 degrees, I can take the 50.1 and subtract from 90. 90 minus 50 is 40. 40 minus 0.1 is 39.9 degrees. And now I have all my sides and all my angles solved for. Here, you try one. Let's try another example here. We're no longer dealing with a right triangle now, as the angle T is 93 instead of 90. So we're dealing with the law of sines or the law of cosines. We're looking for side T. T is opposite the 90-degree angle. So part of my ratio is going to be the sine of 93 over T. The other piece that I need is the a combination that I know. So here I know 15 is opposite angle U. But I don't know angle U yet, so I have to figure it out. When trying to find a missing angle, we take 180 and we subtract the addition of the two angles that I know. So 180 minus 93 plus 41 is going to be equal to 46. So angle U is going to be 46 degrees. So now I know that the sine of 46 is going to be over 15. I can now treat this like a regular proportion. So I have, if I cross multiply here, I can get 15 sine of 93, and I'm going to divide by the sine of 46. Putting this into my calculator, I get a total of 20.82 or 20.8. Here, you try one. For our last example, we're going to find the measure of angle E. So I can see that in this example here, I have two sides, two or more sides. And whenever I have two or more sides, we're thinking law of cosines. If I have two angles, two or more angles, I'm thinking law of sines. So with two or more sides, let's use the law of cosines to find angle E. So essentially, I have E squared equals D squared plus F squared minus 2 times D times F, all times the cosine of E. All right, let's start to put our substitute some of our values in here. So E squared is going to be 10 squared is equal to 14 squared plus 13 squared minus 2 times 14 times 13, all multiplied by the cosine of E. All right, let's start to evaluate some of this. So 10 squared is going to be 100. 14 squared plus 13 squared, if we run the calculator right here, we have that as 365 minus 2 times 14 times 13, which is 364, times the cosine of E. We'll just use the one from the previous line. All right, let's start to solve here. I'm going to subtract 365 from both sides. When I do that, I get negative 265 equals negative 364 cosine of E. I'm now going to divide both sides by negative 364. Okay, and now I'm going to take the inverse cosine. So if I go down here, inverse cosine of negative 265 over negative 364. And when I do that, I get 43.27 or 43.3 degrees. And that is the measure of angle E. Here, now you try one. All right, thanks for following along with today's video. If you find that you have any questions before Thursday's test, feel free to send me an email or a screenshot of an example, and I'll send you some feedback in return. All right, I'll see everyone then.